In this lecture, we will discuss about complex number. So basically, we are going to start a complex analysis. So in complex analysis, we discuss about the basics for required complex analysis. That means first we start with a complex number. So we start the topic complex number. So what do you mean by complex number and how to use these numbers? So we start with the basic definition of complex number. So for defining the complex number, we write down this, let x and y be the real variables. Then the ordered pair. So we write down the ordered pair as x, y is called a complex number with real part x and imaginary part y. As imaginary part y, follow the conditions. So obey rules, that means the conditions. So that we can write down as x comma 0, order pair x comma 0. This gives only the real number. Second, so we have a 0 comma 1. So that means real part is 0, order pair x. We write down the real part of x. So this we can write down this as iota. So third, so when we have a two order pairs, so x1 comma y1, which is equal to x2 comma y2. So two order pair are said to be equal if x1 is equal to x2 and y1 is equal to y2. So you have to remember these condition. And the fourth condition is that so x1 y1 plus x2 y2. So this equal to when we add two complex numbers, so the this can be added as x1 plus x2 and y1 plus y2. So we add the real variable with real variable and complex imaginary variable with imaginary variable. So the fifth one is when we have a two order pair means two complex numbers, so we are going to multiply. So x1 y1 into x2 y2. So x1 y1 into x2 y2. So when we do the multiply of two numbers, so then we can write down this as x1 x2. So we multiply x1 x2 real number minus y1 y2, and second x1 y2 plus x2 y1. So we follow these five conditions. So that means basically we write down this as, so when we have the real part we write down as x, and imaginary part we write down as y. So real part is x, imaginary part is y. Now, so we are going to prove the important thing is which is to prove that x plus iota y is equal to xy. So how to write this into the order pair form? So x plus iota y is equal to xy means an order pair. So I have to write this complex number into the order pair form. So for proving this, so we write down. So we have LHS. So we have LHS is x plus iota y. So this x plus iota y, we can write down this as per the above conditions. So that means first is a real number x. So this x we can write down as x comma 0. So that means x is equal to, the first condition is that x, which can be written as x comma 0. So means y is 0 and plus iota. So iota we can write down 0 comma 1. So iota you can write down as 0 comma 1 into y. So y we can write down as y comma 0. Y comma 0. Now we solve this. So y solving this, so x comma 0 plus. So when we are going to the product of two order pairs, so that we use the fifth condition. Fifth condition means, so 0, fifth condition, so x1 into x2, so 0 into y, so 0 into y minus, and y1 minus y1 into y2, so y1 into y2 means 1 into 0, 1 into 0 comma x1 y2, x1 y2 0 into 0, so 0 into 0 plus x2 y1, so x2 y1 means 1 comma 1 into y, so 1 into y. So this gives us, so first term is x comma 0 plus second term will be 0 into y 0. So 0 into y 0 or minus 1 into 0 0. So this gives us 0, 0 comma 0 into 0 0 plus 0 plus y gives us y. So x0 plus 0y. So this when we add, so when we add these two numbers, so we use the fourth condition. So when we use the fourth condition, so x1 plus x2 and y1 plus y2. So x1 plus x2, x2 means 0 and y1 plus y2 means 0 plus y. So this gives us xy. Okay, so we have proved this one. So x plus iota y can be written as x or in order pair x, y. Now we move to the further. So what further thing? That means to prove that. So to prove that iota square is equal to minus 1. So how to prove this iota square equal to minus 1? So we do the same thing as previous. So that means we write down as LHS side. So iota square you can write down as iota into iota. So iota into iota. So iota we can write down as 0 comma 1 in order pair. So 0 comma 1 in order pair. Okay. So now, so when we do the product of two order pairs, so similar we think we do the x1 into x2. So x1 x2. So 0 into 0 minus y1 y2, 1 into 1 comma x1 y2, so 0 into 1 plus x2 y1, so 1 into 0. So this can be written as 0 into 0 0, 0 minus 1, and here is 1 and 0 into 1 and 0, or plus this gives us 0. So 0, so this can be written as minus 1 into 0. So minus 1 into 0. So this gives us the real value. That means you see the first condition. So x comma 0 equal to x. So this gives us x. Here is x is minus 1. So this gives us minus 1. So we have proved the iota square. The value of iota square is equal to minus 1. Now we move to the further. So when we move to the further, so that means we draw the xy plane. So while drawing the xy plane, so this is the origin. So here we the direction we take as y and this can take as x. So here we take a point z. So we do the small z. So the coordinate of this z is x comma y. So that means in the positive axis. So this plane we write down as, this plane is called complex plane. So we or complex plane, or also called the Gaussian plane. This is also called the Gaussian plane, or also called the Argand plane. Basically, we would take the coordinates z and write in the form of the order pair. So z is the variable. So now what is the advantages of this? So for writing the advantages, so z we can represent it by a point. So we write down as z is represented by a point. So the complex number that is also represented by a point, and this is our first condition. And the second thing, R means real number is subset of the complex number. So we remember one remark for this one also. So what is the remark? So the order relation. The order relation less than or greater than does not hold in the set of complex number. So we remember this thing. For example, we can write down as 1 plus iota is greater or less 1 minus iota. So we cannot see that, which may be greater than or less than. Now, first we have the Cartesian form of the complex number. So Cartesian form of the complex number, you understand that we take the order pair xy. So x or y represent the Cartesian form. So now we move to the polar form. So we write down the polar form of complex number. So for converting the polar form, so we take a point z, z in the order pair of xy. So here we have the point z. So this distance we write down as this is x, and here we take as y, and this is the radius r, and making angle theta with this. So we write down x is equal to r cos theta, x equal to r cos theta, and y is equal to r sin theta. Okay, so we know on trigonometry. So when we write down as x plus iota y, so x plus iota y, so this can be written as r cos theta plus iota r sin theta. So we take r as common, so we write down as cos theta plus iota sin theta. So by using De Moivre theorem, so this gives us r e raised to the power iota theta. So the variable z is equal to x plus iota y is equal to r e raised to the power iota theta. Okay, so when we obtain the modulus of the complex number, so here we move to the modulus of complex number. So modulus of the complex number. So suppose z z equal to x plus iota y be the complex number, and the absolute value or modulus of z is equal to plus minus. So we take the positive sign only. So x square, real part to the whole square, plus imaginary part to the whole square. So because the absolute value, so this is the modulus. Modulus is a non-negative real valued function. Now we write down as x plus iota y. X plus iota y is equal to r cos theta plus iota r sin theta. So when we do the square of real part and imaginary part, x square plus y square is equal to r square cos square theta plus r square sin square theta. So this we can write down as r square cos square theta plus sin square theta. So we write down that this is equal to r square. So x square plus y square is equal to r square. So this r gives us square root of x square plus y square. So square x square plus y square. So we have a absolute value z. That means z is equal to r. So mod of z is equal to r. That means modulus of z is equal to r. We can write down this as equal to r. Similarly, when we calculate the theta, so, theta is equal to argument of z. So argument of z is equal to, we can write down the amplitude of z. So amplitude of z is equal to tan inverse y upon x. So this will be the tan inverse y upon x.